So in the last lecture, we saw how you could find the equation of a parabola, a quadratic equation, through 2 points if one of the points was special, right? If one of the points was the vertex. Okay, what if none of the points are special? What if either none of the points are the vertex, or at the very least, you don't know that they're the vertex? Well, turns out we can still do this. However, in this scenario, you need 3 distinct points to make this happen. Okay, so how do we do that? Well, since all we know are arbitrary points, we're going to have to use the arbitrary equation. We're going to have to use just the generic equation for a quadratic function. We're going to use y equals ax squared plus bx plus c. And to do this, we need to be able to calculate the values of a, b, and c given our 3 points. All right, so here's how we're going to make that happen. I'm going to take those points and I'm going to substitute them one at a time into the equation. All right, so if I do that, let's do 1, 0 first. Right, that gives me a plus b plus c. I just put 1 in for x equals 0. And if I put 2, 3 into there, I get, let's see, I'm putting 2 in for x. So this is 2 squared 4a plus 2b plus c equals 3. And then I'm going to do it with the last point, negative 3, 28. Now, so let's see, if I put negative 3 in for x, this is negative 3 squared. That's 9a minus 3b plus c equals 28. Now, look at what I have here. I have a system of linear equations. I have 3 equations and 3 variables. Awesome. I should be able to solve these for a, b, and c. Right? And I'll walk through the process here, just so you can see how it's done. There are online websites that will do this for you, although the notation they require you to enter things in can be a little finicky. So we'll go ahead and do it by hand. All right, so I'm going to start by working with equations 1 and 2 here. I'm going to multiply equation 1 by negative 1. So I'm aiming to eliminate the c's. One of the nice things about doing this is it's always going to be, at every equation is going to end in plus c, right? Because if you look back up at the original, there's no variable on the c, right? So it's always going to be relatively straightforward to eliminate the c's and then see what you get. All right, so this will be negative a minus b minus c equals 0. 4a plus 2b plus c equals 0. And if I add these together, I get 3a plus b equals 0. Okay, so next I'm going to do this again, but this time I'm going to do it with equations 2 and 3. Right, I'm going to do this over to the side here. Right, I'll multiply the first one by negative 1, so I'll be negative 4a minus 2b minus c equals minus 3. And the other one, 9a minus 3b plus c equals 28, stays the same. When I combine these together, what do I get? It's 5a minus 5b equals 25, and I can't resist. I'm going to divide everybody by 5, right? Just because I can, and it's always nice to make the number smaller. This will become a minus b equals 5. Excellent. Now, look at what I've got here. First, I noticed I made a little mistake over here. This should be a 3, not a 0. So this will be a 3. And that's gonna work out nicer, right? I just copied it wrong. It should have been this 3 here. I was looking back at the 0 from the previous equation. So let's write these. I'm going to put a minus b equals 5 under here. Now I can add them together. See, this is nice. The b's are going to cancel. I get 4a equals 8. A is equal to 2. Now I'm going to take this, drop it into here, and I get 2 minus b equals 5. Minus b equals 3. So b is negative 3, and then I'm going to take both of these two, put them back into the first equation, and I'll get 2 minus 3 plus c equals 0. Negative 1 plus c, so c is equal to 1. And now I have my equation. Y is equal to 2x squared minus 3x plus 1. That's my answer, right? And again, you can check this. It's a little messy, but you can take 1, 2, and negative 3, substitute them into the equation, and confirm that you do get 0, 3, and 28 back out. Right, so I've got one more example here for us to look at, and this one is this one has a problem, right? And I picked it knowing that it had a problem because I want you to see what it looks like when we run into this situation, right? So I'm going to do the same thing that I did before, right? I'm going to start with y equals ax squared plus bx plus c, and I'm going to put my points in. Negative 1, 0 gives me a minus b plus c equals 0, and if I put 4 comma 1 into here, I get 16a plus 4b plus c equals 1, and finally if I put negative 1, 4, I get a minus b plus c equals 4. Well, if you didn't see it before, hopefully you're starting to see where the trouble is going to start. I'm going to start by trying to combine equations 1 and 3. So let's multiply. I'll multiply the first equation by negative 1. Negative a plus b minus c equals 0. Equation 3 is a minus b plus c equals 4. You add these guys together, and you immediately run into a problem. 0 equals 4. No, it does not equal 4. So what happened here? Well, this system of equations has no solution. Right, so what that means is there is no quadratic equation. Let me qualify that. There is no up-down quadratic equation that passes through those points. And if you look at them, you hopefully can see why. You can see that it's equation 1 and 3 had a problem, so it's points 1 and 3 we should be suspicious of. And if you try to graph this, you get the point negative 1, 0, the point 4 comma 1, and then our second point is the point 1, negative 1 comma 4. Okay. Those two are directly above and below each other. They're on a vertical line, if you will. And that can't happen. A parabola never goes straight up and down. I mean, it can be going pretty fast. Once the x values start to get large, it can start to kind of look like it is, but it's not. Right? And that's where the trouble lies here. Now, it's worth pointing out there absolutely is a left-right facing parabola that goes through those points, right? And you could find that easily enough. You're just going to start with the left-right version of the equation. You would start with x equals a y squared plus by plus c, and then you're going to put these points in. If you put negative 1, 0 in here, well, this is nice. You get negative 1 equals 0a plus 0b plus c. C is equal to negative 1. You see already you're on the high road. You've got a third of your values there. Do that with the other 4 points. You'll get another system of 3 equations, 3 variables, and you can solve that just like we did on the previous slide. So this brings us to the end of kind of our focused discussion on specifically quadratic polynomials. So in the next chapter, we're going to kind of circle back and talk about factoring again. We're going to look at some additional tools that you can use, not so much to factor polynomials. They are procedural, like things like factoring by grouping that we talked about earlier. They're intended to kind of give you direction, saying, look, if this polynomial equation has rational solutions, this is what they have to be. So then you can go back and test those values and see, which ones on this list work and which ones don't.